Imagine if two particles, separated by light years, could instantly share information, as if they were connected by an invisible thread that transcends space and time. A change in one instantly affects the other, no matter the distance. Sounds like science fiction, right? But this is not fiction. It's one of the most mind-bending realities of modern physics, quantum entanglement, and it's paving the way for a future where quantum teleportation and ultra-secure communication systems become part of our daily lives. Welcome to the Learning Studio, and in today's episode from our physics playlist, we'll explore one of the most fascinating phenomena in all of science, quantum entanglement and teleportation. You can watch the entire physics playlist by clicking the link below in the description. This episode is part of our section Quantum and Relativistic Revolution, where physics meets computation, where we uncover how quantum reality is reshaping the digital world. The Einstein-Bohr debate, spooky action at a distance. In the early 20th century, Albert Einstein and Niels Bohr engaged in one of the most profound debates in science. Einstein believed that the universe followed predictable laws, that every effect had a clear, local cause. But Bohr, guided by quantum mechanics, argued that nature is inherently probabilistic, uncertain until measured. Then came the phenomenon that even Einstein couldn't accept: entanglement. Two particles can become so deeply linked that measuring one instantly determines the state of the other, even if they are light years apart. Einstein called it spooky action at a distance. But experiments in the late 20th and 21st centuries proved it to be real. What is quantum entanglement? When two quantum particles interact, say, two electrons or photons, their properties can become correlated. They share a joint quantum state, described not individually, but as a single, inseparable system. For example, if one photon is measured and found to spin up, the other, no matter where it is, will instantly be found spinning down. This isn't because one signal travels faster than light, rather, both particles are part of the same quantum state that extends through space. In quantum physics, space and distance don't limit connection, information exists in relationships, not in location. This realization doesn't just redefine communication, it redefines what we mean by separation. Quantum teleportation, information beyond distance. Now comes the truly astonishing part: quantum teleportation. No, we're not talking about teleporting people or objects, but quantum information itself. Using entanglement, scientists can transmit the state of a particle, its entire quantum information, from one place to another without physically sending the particle itself. This is achieved by combining entanglement, measurement, and classical communication. Here's how it works, simplified. Two particles, A and B, are entangled. A third particle, C, whose state we want to teleport, interacts with A. Through a clever measurement and classical communication, the quantum state of C is transferred to particle B, perfectly recreating the original quantum state. The result? Information teleportation, instant, secure, and without copying the original state. This process doesn't violate relativity, because no physical object or faster-than-light signal travels between them. But it does reveal that information, the fundamental currency of the universe, can move in ways classical physics never imagined. Quantum networks and secure communication. Quantum teleportation is more than a theoretical curiosity. It's the foundation of the emerging quantum internet, a global network that uses entangled photons to transmit data securely. Unlike classical systems, quantum communication can't be hacked without detection. If anyone tries to intercept the entangled link, the quantum state collapses, revealing the intrusion instantly. This is called quantum key distribution, QKD, a method already being tested by companies and governments around the world. China's MISHAS satellite, for example, has successfully demonstrated quantum communication between space and Earth, proving that long-distance entanglement is not just possible, it's already happening. In the coming decade, quantum networking will redefine cybersecurity, cloud computing, and even global communication infrastructure. AI and quantum connectivity. Artificial intelligence is also stepping into the quantum domain. By combining AI models with entangled data systems, researchers are developing quantum neural networks, where information processing happens in parallel across entangled states. This could dramatically speed up optimization, learning, and even decision-making in autonomous systems. In short, the fusion of AI and quantum entanglement may create computers that think using the same probabilistic, interconnected logic that governs the universe itself. A universe without separation. Quantum entanglement and teleportation show us a reality where everything, from particles to minds, might be deeply connected. It challenges the old idea of an isolated universe and replaces it with one of interdependence and information flow. Every bit of matter, every photon of light, is part of a cosmic network of relationships, an intricate web of quantum links that make up existence itself. This is the Learning Studio, and this was our episode on quantum entanglement and teleportation. If this glimpse into the strange yet beautiful side of physics sparked your curiosity, make sure to subscribe, like, and check out the physics playlist linked below. In our next video, we'll explore quantum gravity and the unification quest, where physicists are trying to merge the largest and smallest scales of the universe into a single, elegant theory. Because in physics, just like in the universe, nothing is ever truly separate. Everything is entangled.